All right, so today we're diving into some of the coolest ways radio waves travel and bend to keep us connected, even over crazy long distances. First up is something called sporadic E propagation. What happens here is that our atmosphere develops these really intense, tiny pockets of ionization. Think of them like charged clouds, and they reflect radio waves. This typically happens between 90 to 120 kilometers up in the atmosphere, and it's extra common during summer months. So these pockets let us send signals way farther than usual, like 800 to even 2,000 kilometers away. But the science behind it, still kind of mysterious. Is it meteor debris, wind patterns, maybe atmospheric disturbances? The truth is, scientists are still piecing that part together. Now let's talk about meteor scatter propagation. Picture this, a meteor zipping into Earth's atmosphere. As it burns up, it leaves behind an ionized trail, and this trail actually bounces radio signals. It's not long-lasting, just like a second or two, but it's super effective for communication over long ranges, sometimes up to 2,300 kilometers. And here's the kicker. This works best during meteor showers, when you've got more meteors than usual lighting up the sky. It's like nature's own data highway in action, and amateur radio enthusiasts really maximize this during showers to connect with people far away. But it doesn't stop there. Auroral propagation is a whole other story. This one's tied to the magic of solar activity. When solar wind interacts with Earth's magnetic field, it creates an aurora, that shimmering, colorful light show in the sky. What's wild is that these auroras ionize parts of the atmosphere, making it possible for radio waves to ping off and reach places as far as 2,000 kilometers away. Though, I gotta say, the sound? It's pretty funky, kind of fluttery and distorted, because of rapid signal fading. And auroras aren't exactly your everyday phenomenon. They're more common when the sun is in a really active phase. And then there's this super cool phenomenon called tropospheric ducting. Picture warm and cold air layers stacking up in the atmosphere, almost like an invisible pipe that guides radio waves. This happens because of temperature inversions, often caused by high-pressure weather systems. When conditions are just right, signals can travel more than 1,000 kilometers, seriously far beyond normal limits. Talk about weather working in your favor. The only catch is, you can't always predict when this will happen. And, of course, we can't leave out the powerhouse, the F region of the ionosphere. This region's all about solar radiation ionizing the atmosphere during the day, enabling high-frequency radio waves to reflect back to Earth. It's the reason why HF signals can travel thousands of kilometers. At night, though, the behavior changes. The F1 and F2 layers merge, and signals don't travel quite the same way anymore. Super fascinating stuff to think about. Now, here's where I think it gets really exciting. Experimentation. If you're into this kind of thing, you might want to try building a basic radio kit. Play around with line-of-sight communication, like seeing how terrain or elevation affects how far your signals can reach. It's such an awesome, hands-on way to understand how all this fits together. And let me tell you, I've had my share of failed experiments back in the day. Once I thought I had the clearest connection, only to learn my antenna wasn't even properly secured. Oh man, talk about a reality check. But also, that's how you learn, right? And before we end, just remember, curiosity and good research are your best friends in science. There's a lot of bogus stuff floating around online, especially about things like solar storms and radio outages. Stick to trusted sources, double-check your facts, and you'll be golden. All right, that's all for today. Thanks for tuning in and exploring the wild world of radio waves with me. Until next time, stay curious and keep experimenting. Talk soon.